Hello. Today we're going to talk about the 5 strands of mathematical proficiency. Knowing mathematics is more than just finding the correct answer. It's about successfully learning the subject through a larger, more comprehensive lens. As noted in the book Adding It Up, this framework is incredibly useful for analyzing qualitative classroom data, helping us look just beyond just test scores to understand students' thinking and dispositions. The 5 strands: conceptual understanding, procedural fluency, strategic competence, adaptive reasoning, and productive disposition, are interwoven and interdependent, and we will see how they come to life in a single, well-crafted word problem. Here's the word problem we'll use as our example. It's an Algebra 2 problem involving linear and rational functions. The goal is not just to find the answers, but to use this task to assess and cultivate a student's full mathematical proficiency. Let's start with the first 2 strands. Conceptual understanding is all about a student's grasp of the why. We can assess this by asking them to explain why the $100,000 fixed cost is a constant and the $200 per phone is a variable cost. Do they understand what the horizontal asymptote represents in this context? That the average cost is approaching the variable cost? Procedural fluency, on the other hand, is the how. We can assess this by looking at their ability to accurately write the correct functions and perform the calculations. The beauty of this problem is that they need both. Without conceptual understanding, they can't set up the functions, and without procedural fluency, they can't solve them. Next, we have strategic competence and adaptive reasoning. We can assess strategic competence by looking for a student's ability to plan and execute a solution. For example, did they know that they must first write the total cost function before they can write the average cost function? Did they strategically apply their knowledge of asymptotes to answer questions about the function's behavior? Adaptive reasoning is about the justification, the why does this make sense part. Can they explain in their own words why the average cost decreases and why the horizontal asymptote is a logical limit? Can they justify why the vertical asymptote at x equals 0 is significant in the context of the problem? This is where they connect the abstract math to the economic principle of economies of scale. Finally, we have productive disposition, which is the I can do this strand. When students see how a complex problem like this can be successfully modeled using math, it builds their confidence. We can assess this strand by observing their engagement and persistence with the task. Do they get discouraged easily, or do they stay with the problem? They develop a positive attitude towards math because they see it as a powerful and relevant tool, not just a set of arbitrary rules. Problems like this, which connect algebraic concepts to business and economics, help students develop a belief that with effort they can master challenging mathematics. In conclusion, this smartphone production problem isn't just about finding the right answer. It's a vehicle for developing mathematical proficiency. By designing problems that require students to think conceptually, apply procedures strategically, reason adaptively, and feel a sense of accomplishment, we can help them become truly proficient in mathematics. To conclude, this presentation marks a shift in my perspective as both a learner and an educator. This course challenged me to move beyond traditional textbook problems and embrace the full scope of mathematical modeling. It's one thing to solve a quadratic equation, but it's another to build that equation from a real-world scenario, analyze its behavior, and justify its limitations. This is where the 5 strands of mathematical proficiency become the essential lens for truly understanding what it means to be successful. As a learner, this framework has given me a new way to understand my own thought process. It's no longer enough for me to just find the right answer. I now see the importance of all 5 strands. As an educator, this reflection is even more crucial. I now understand that my instructional practice must be designed to nurture all 5 strands. I will intentionally create tasks that require students to think conceptually, use their procedural skills, develop a strategic plan, justify their reasoning, and build a productive disposition by seeing themselves as capable problem solvers. The 5 strands are not just a theory, they are a practical framework for designing instruction that goes beyond rote memorization, helping me to develop students who can truly think like mathematicians.